We're going to take a look at some file encryption and data encryption with this packet tracer. We want to make sure that we are logged in on our packet tracer. Once we're logged in, the background on this explains that while this is some encryption and decryption, it is not at the level that you would want to use in production, either at your home or your business. These are just tools to show us the background of what encrypted and decrypted data look like and how hackers or threat actors could access our data if we don't have it encrypted to production standards. We'll also need to use our virtual machine in this lab. If you have not installed one on your computer, then you will need to use the net lab provided at the college. Please reach out and we'll make sure that you have access if you have not already signed in. Part 1. Mary's laptop is named Laptop BR1 in the branch office. Mary has a text document on her laptop that contains her FTP login information in encrypted form. An FTP login is for an FTP server. So on this particular packet tracer, the FTP server is called BR server, and it's located in the branch wiring closet. So we're going to go to Mary's laptop. We'll look at the devices within the branch. The top left one there is laptop BR2. At the bottom here we have PC BR1. We also have a printer, BR printer. Our server is in this branch wiring closet, so we don't have access to physically open it and get there. So we may need to remote into it from our devices. This little laptop here is Mary's. It's laptop BR1 is the name of it. So we'll open it up and go to the desktop and the text editor. File, open. We want to open Mary's FTP login text. Once you open that up, you'll notice that this data is encrypted. That's definitely not plain text. We can't read it. Knowing what level of encryption it's at is the biggest thing. Luckily, our packet tracer tells us that. So we want to copy the information from her login. And this is how you would do it in production. We're also going to go to our virtual machine and we're going to open our terminal. Now here's where we would type in this command. Linux commands are very case sensitive and space sensitive. I find for the purposes of packet tracer, it's easier just to copy those. And we're going to paste them in here. Now if we look at that command, what that has is echo at the front, which means we're asking Linux to tell us something, echo it back to us. But we've asked it to use OpenSSL and use the AES 256 CBC option to decrypt our file. The PBKDF2 option enables password-based key derivation, it's hard for me to say, function to, it applies a hash-based message authentication code. Most people refer to that as HMAC, to the password along with salt. The -A at the end here shows us, it tells OpenSSL to encode the encrypted message using a different encoding method of base 64, and the -D tells the application to decrypt the data. We're told to use the Mary FTP123 password here. And that gives us the information for the account. Username is Mary, all lowercase. The account information is capital M in Mary, but the username is lowercase Mary. The password is Cisco321. So now we want to use that information to be able to access the FTP server. So we're going to return back to our packet tracer to BR1. Let me minimize that. Mary works for a credit card agency and needs to send the agency a file that contains the data of some customers. So we're in part 2. We're going to verify that the data is encrypted before we upload it to the server. So we're returned to BR1. We're going to open back up the text editor. File, open. We're going to look at this client info .enc. The .enc stands for encryption. So once we open it up, it asks us what form the data is in. That's definitely not plain text. It is definitely encrypted. I can't read it, so that's what we're going to answer that question with. Step 2, we're going to connect to the BR server. So to do that, we're going to close the text editor and we're going to open the command line. And the command to connect to a server, an FTP server, is FTP, and then you'll put in the address of that device. It's asking for our username, so it's lowercase Mary. It says username's okay, but now we need the password, and it's Cisco321. So we are logged in. Now we're going to type in dir as the command to give us the directory and show us what files are on the server. Once we've seen what's there, now we're going to upload our client info file to be accessed from another user. To upload a file on an FTP server, the command is put. Shows that we've successfully uploaded 564 bytes. So we'll close that. Step 3, we've already uploaded the file. I'm sorry, we were supposed to type quit and not exit to get out of that. So if a threat actor were to see, there we go, quit. If a threat actor were to catch that file in transit from laptop BR1 to the FTP server, the things that would be in clear text would be Mary and her password, the file itself is already encrypted, so that would not be in plain text. But the fact that Mary put in her username and her password in plain text, and the connection with an FTP server is not encrypted, then that would be in plain text. We do have SFTP servers, which are secure FTP servers. Those connections are encrypted, so the username and password would not be visible if that file were to be captured. The transfer process, anyway. So, step 3, we want to Bob needs to access the contents of Mary's file that she stored on the server and verify some of his customer information. Like Mary, Bob needs to decrypt his FTP login information before he can access the BR server and download the file. So we'll look in the branch office and find Bob's computer, and that is laptop BR1. It's over here on the left. I'm sorry, BR2. It's over on the left. We'll go to the desktop and the text editor. File open. There's Bob's FTP login information. Again, it's encrypted, so we need to be able to decrypt that to find his login information. We'll use the same parameters that we used with Mary's. This time our password for the decryption is Bob FTP123. We're given the username of all lowercase Bob. Password is Ninja123. Now, mind you, my workstation here, the virtual machine, is active connection to the internet. This is really happening in the background. I can ping Google from this device real time. So the information is coming from the OpenSSL service for us to complete this lab. Packet Tracer does not have active connection to the internet, and that's why we have to use the virtual machine to take care of this. So the username and password for Bob's account is back up here, lowercase Bob, password Ninja123. Minimize that. We're going to go and download the confidential data using FTP. So Mary uploaded it. Now we're going to be Bob and download it to our device. We're going to close the text editor, open the command prompt, and FTP to the server. Our username is Bob. Username is okay. Now we need the password. NINJA123. Great. We are logged in. We want to look at our directory. We see that the client info encrypted file is there, so we want to get. So we put the file there as Mary, now we're getting the file as Bob. So once we've gotten the file, we want to be able to view it. So we're going to decrypt the client info.enc file. Again, if the threat actors were able to capture that file transfer, it would have been the same thing. Bob and his password would have been in clear text, but the file itself would have remained encrypted. So now that Bob has the file, he needs to decrypt it. We're going to close the command prompt and open email. Our email's here. Mary has sent an email to Bob giving him the decryption key. So the decryption key is Cisco 123. We're going to close the email window and open the text editor window. Open client info. We will copy all that. We're going to go back to our live virtual machine. And look for our text editor. We don't have a shortcut built onto that, so you just type the word in at the top. Pluma will come up. Once you've opened Pluma, edit, paste. So there is all of our encrypted data from the client info file. We're going to File, Save As. We want to name it. clientinfo.enc. There we go. I've done this lab before, apparently. So once we've saved it, we want to in the terminal enter ls command to verify that it is in the current directory. Sometimes, depending on where you were working last, you may be in a different directory. So I'm going to hit dir, make sure client info is in fact there. If it had gone underneath desktop or under documents, then we would need to change directory to be able to access it. So now that we've made sure that it is stored in the directory that we're currently in, we want to issue the command open SSL for the client info enc. That's what we want to put in it. We're going to get out of it the client info.txt. So it's asking for the password. And that was the Cisco 123. That was the email that Mary sent Bob to tell him what the decryption password is. So now we're going to list and we see that we have clientinfo.enc and clientinfo.txt. So we could actually open with Puma. So now this is the encrypted data. Open SSL as decrypted it, and there's our name, address, and credit card number for each of these clients. So now we want to make sure we take our screenshot. You want to make sure your date and time is on there. Don't cover your name at the top. So we'll get our date and time on there. You may have to leave your virtual machine out of there because that was just taking it in the virtual machine. So now we get our date and time. Let's try it this way. There we go. Now we can take our full screenshot and submit that on our Word document. We are at a completion of 100%. We have our date, time, and our name on it. I hope this helps you guys. If you have any questions, feel free to reach out. Have a great day.